Hey guys, in this video we will be going over some special factoring techniques. So recall that the product of the sum and difference of two terms, say a and b, is the following special product. We have a plus b times a minus b is equal to a squared minus b squared. Reversing this equation gives us a factoring pattern, which we use to factor the difference of two squares. So a squared minus b squared equals a plus b times a minus b. And to use this equation, we must first be able to recognize when a binomial with two terms is a difference of two squares. So a binomial will be a difference of two squares if both terms are squares and if the binomial is a difference. Let's practice using this pattern and seeing if we can recognize when a binomial is a difference of squares. So we want to factor the following polynomial. Since this is a binomial, we want to see if this is also a difference of two squares. If so, then we can factor it using our formula a squared minus b squared equals a plus b times a minus b. The first term, x squared, is already written as a square, and the second term can be written as a square if we write 4 as 2 squared. And since the binomial is a difference, we have a difference of two squares. Therefore, we can use the following formula. So following the pattern, x is a and 2 is b. So our factored form is x plus 2 times x minus 2. And now we have factored the polynomial. For the next example, we also have a binomial, so we want to see if this is a difference of two squares. Right away, we see that this is a difference, so that condition is satisfied. The first term, x squared, is already written as a square, and the second term can be written as a square if we rewrite 25 as 5 squared. So the binomial is a difference of two squares. Therefore, we can use the formula to factor this. So following the pattern, x is a and 5 is b, our factored form is x plus 5 times x minus 5. And we have now factored the polynomial. For the next example, we also have a binomial, so we want to see if this is a difference of two squares. So the first term is a square, and so is the second term, since it can be written as 4 squared. But this is not a difference, therefore our formula does not apply. This binomial cannot be factored, so we can say that it is not factorable or prime. For the next example, again, we have a binomial, and this can be written as a difference of two squares. 4x squared is a square because it can be rewritten as 2x quantity squared, and 1 is a square because it can be written as 1 squared. So using our formula, a is 2x and b is 1. The factored form is 2x plus 1 times 2x minus 1. The next example is also a difference of squares. This can be written as 5x quantity squared minus 3y quantity squared. Therefore, using our formula, a is 5x and b is 3y, the factored form will be 5x plus 3y times 5x minus 3y. And for this example, this will also be a difference of two squares. The first term is a square since it can be written as x squared quantity squared. And the second term is also a square because it can be written as 4 squared. And using our formula, a is x squared and b is 4. We get x squared plus 4 times x squared minus 4. But this time notice how we have another difference of squares as one of our factors. Therefore, this is not fully factored. To factor x squared minus 4, we will use our difference of squares formula again, where a is equal to x and b is equal to 2. We get x plus 2 times x minus 2. And now our factored form is x squared plus 4 times x plus 2 times x minus 2. So sometimes we will have to factor out the greatest common factor first, and be sure to factor completely. Always check to see if any other factors can be factored further. So it's always helpful to ask yourself, can I factor again? So for example 2, we want to factor completely. For this binomial, first notice that the two terms have a GCF of x. We must factor this out first. So we have x times 4x squared minus 49. And now notice that this is a difference of two squares. This can be written as 2x quantity squared minus 7 squared. And using our formula, a will be 2x and b will be 7. So this will factor to 2x plus 7 times 2x minus 7. And since we can't factor any of these three factors any further, we're done. So our polynomial is now fully factored as x times 2x plus 7 times 2x minus 7. For the next example, again, we want to see if there's a GCF that we can factor out first. These two terms have a GCF of 2. So we factor this out first. So we have 2 times 81x to the 4th minus 1. Now notice that this is a difference of two squares, since it can be written as 9x squared quantity squared minus 1 squared. So we can factor this using our formula. So a is 9x squared and b is 1, and this will factor to 9x squared plus 1 times 9x squared minus 1. And we are actually not done yet because we have another difference of two squares here, since we can rewrite this as 3x quantity squared minus 1 squared. So a will be 3x and b will be 1, and this factors to 3x plus 1 times 3x minus 1. And now, since we cannot factor any of these four factors any further, this will be our factored form of the polynomial. So we can also factor the sum and difference of two cubes. So for example, x cubed minus 8 is a difference of two cubes. X cubed is a cube because it is raised to the third power, and 8 can actually be written as a cube if we rewrite it as 2 to the third power. And x cubed plus 27 is an example of a sum of cubes, where x cubed is a cube since it is raised to the third power, and 27 can be written as a cube if we rewrite it as 3 to the third power. So you want to be able to recognize if a binomial is written as a sum or difference of cubes. So the formula we use to factor a sum of two cubes is the following. And the formula we use to factor a difference of two cubes is the following. They're very similar, so be careful not to mix the two up. We have a plus sign here for the sum of two cubes, and a minus sign here for the difference of two cubes. And we also have a minus here for the sum of two cubes, and a plus sign here for the difference of two cubes. And a helpful mnemonic is SOAP, where S stands for same, O stands for opposite, A stands for always, and P stands for positive. So for example, if we look at the sum of two cubes formula, we have the same sign here, opposite signs here, and the last term is always positive. And the same thing works if we look at the difference of two cubes formula. We have the same sign here, opposite signs here, and the last term is always positive. So let's try some examples where we can apply these formulas. For this example, notice that the binomial is a difference of two cubes, since this can be written as x cubed minus 4 cubed. Therefore, we can use our formula for factoring a difference of two cubes, where x is a and 4 is b. So we have x minus 4 times x squared plus x times 4 plus 4 squared. Simplifying this, we get x minus 4 times x squared plus 4x plus 16. And now we have factored our polynomial. For the next example, we have a sum of cubes this time, since this can be written as 4x quantity cubed plus 5 cubed. So we will use our sum of 2 cubes formula to factor this, where a is 4x and b is 5. So we have 4x plus 5 times 4x quantity squared minus 4x times 5 plus 5 squared. This simplifies to 4x plus 5 times 16x squared minus 20x plus 25. And now we have factored our polynomial. And for the last example, it looks like we can't write this as a difference of cubes, but we can actually factor out a GCF of 3. Again, this is always what you want to do first if possible. Now we have a difference of 2 cubes here, since we can rewrite this as x cubed minus 3 cubed. So using our difference of 2 cubes formula to factor this, where a is x and b is 3, we get x minus 3 times x squared plus x times 3 plus 3 squared, which simplifies to x minus 3 times x squared plus 3x plus 9. And now our polynomial is factored.